Good day, matriculants. Let us together tackle this short objective question. Okay, 1.1.1. So we are given this diagram which appears to have a low pressure here, a low pressure on the interior, and then we have two high pressure systems or one high pressure, which would automatically be the South Atlantic High. Okay, and this C is okay. Let's see, this is 1016, this is 1020. Okay, so you see that the pressure moves from 1016 to 1020, right? Meaning that the pressure is increasing, and when increasing pressure results in a high pressure system here, right? So this automatically becomes a South Indian High. So how would it, like, the isobar combination look in a low pressure? It will look something of this nature. It'll have an L here, and then it'll have, I'll use the exact same example, 10, 16 here, and then a 10, 20 here. You see that the pressure as you come towards the center is decreasing. So when you reach the center, actually it'll be very, very less, right? Meaning this is low pressure. So that's how you typically identify high pressure and low pressure on given this type of diagram. Okay, having given that context, I think we forgot to label this low pressure. So low pressure that occurs on the land is called it's called a thermal low, right? It's thermal low. And when low pressure systems occur along the coast here, you'd see something like this. It's a low pressure system occurring on the coast. That's called a coastal low. Coastal low. Okay, with that out of the way, let us answer the questions. Okay, the season shown in the sketch map is the season is summer, right? Why? Because we can see a low pressure on the interior of the land. And how does the low pressure form? It forms because of high evaporation of air. And when does air evaporate? When there's a lot of heat, right? A lot of heat, a lot of insolation. So that's how this low pressure system formed, meaning it is summer, right? So it's summer. And typically you'd see a high pressure system here had it been winter, right? Okay. Uh, and why the other options like are incorrect, spring and autumn, they don't really test on these. We are only like vastly tested on summer and winter. But had we were given a date or anything, a South African date that we'd be familiar with, and we'd know that it's autumn or spring. But even still, I'd still choose either summer or winter to just remain on the safe side. Okay, because I have never seen a past paper that tests spring and autumn. Okay, so 1.1.2, lines on the sketch map that joins places of equal atmospheric pressure. Atmospheric pressure. Okay, those are isotherms join places of equal temperature, right? Those isotherms, thermal temperature, right? Isotherms join places of equal temperature. Iso heights, I don't know what that is. Isobars join places of equal atmospheric pressure. So this is the correct answer. And contours are just lines that join equal height, right? Okay, so let's just grasp this information. So isotherms equals to join places of equal temperature, right? Isobars join places of equal pressure, and then contours or contour lines join places of equal height, right? So you must know the difference between these three just for you to not lose easy marks, right, on these type of sections. 1.1.3. The atmospheric pressure reading at A is something hectopascals. Alright, let's look at A. So we may all conclude that A is a isobar since they told us it reads atmospheric pressure. Sorry for that. It reads atmospheric pressure. Okay, fine. And this isobar happens to be between 1012 and 1016. Alright, cool. So let's check for numbers that are between 1012 and 1016. So A is actually greater than 1016, 1014 is in fact between 1012 and 1016, so this might be our answer. 1010 is less than 1012, so that's not our answer. Now, so C is our answer. And some of you might be asking yourself back at home that how do you know that? So we've concluded that this is 1014, by the way. How do you know that this is increasing and not decreasing to 1012, 1010? Why is 1010 wrong here, right? So this is a low pressure system, right, in the interior of South Africa, meaning that pressure is supposed to be decreasing inwards. So if this is 1012, this isobar would be 1010. Hope you understand. And here, the high pressure system, air pressure should be increasing since it's high pressure, it's increasing, right? So it should be moving from 1012 and a certain number which increases, and then a certain number which increases to 1016. So 1014 fits this scenario perfectly, all right? I hope that makes sense to all of you back at home. So the correct answer here would be C, all right? Okay, so 1.1.4, the elongation of isobars at B indicates something of the South Atlantic high. Elongation of isobars. Okay, so let me just quickly explain this concept. So when you see a high pressure system with elongated isobars, right, we call this ridge, a ridge, right? Ridging or a ridge. And then when you see a low pressure system extending its isobars, we call that a trough. Right? And then when you see these two pressure systems interacting with one another to form something that, now this is looking like shades, but high pressure system would typically be here, low pressure system. When you see these two systems interacting, we call this here a saddle, right? So you should be familiar with these concepts. You should memorize them and like identify them instinctively, right? So what we are asked to identify here is a high pressure system that is extending itself, which is process B, which is ridging, right? Option A. Okay. And by the way, let me just try to get you into context as to why the other options are incorrect. So we know that trough is incorrect because that's an elongation of a low pressure system. So what is backing and veering? So backing is when the cold front of a mid-latitude cyclone passes and the wind direction was, for example, was not, I'm going to say northwest. So after the cold front has passed in the southern hemisphere, it becomes southwest, right? And that is called backing and only occurs in the, southern hemisphere. And why does it occur? It occurs because of the clockwise circulation of the air inside the mid-latitude cyclone. And then the opposite is true for the northern hemisphere. For the northern hemisphere, let's assume that the air was already southwest. The air will change after the cold front has passed. It will change to a northwest, right? And then this we do not call backing, we call veering, right? Veering. Why does veering occur? It occurs because of the anti-clockwise movement of the mid-latitude cyclone in the northern hemisphere. By the way, northern hemisphere cyclones move anti-clockwise, right? But don't pay too much attention to the northern hemisphere. Here we are at the southern hemisphere. Backing occurs southern hemisphere. When wind was northwest, it backs to southwest, right? Why? Because of the clockwise circulation of wind. So I know this is not related to the question at hand, but I'm just trying to give you a bit of insight why these other options were incorrect. All right. And I hope that you did understand that fully. So the air movement at sea is something and something. Air movement of a, where's sea? Okay, a high pressure, South Indian high. Okay, so I'm going to draw for you a simple illustration, right? Just a high pressure, low pressure, and a high pressure. Right. So typically, air moves from high pressure to low pressure. Yes, we learned this in grade 11. This is just a refresher. And then when it converges, this is air converging, right? Convergence. A meets, converge. When it converges, it'll rise. And yes, we learned this in grade 11. So it'll rise. This is rising A. And then when it reaches the upper atmosphere, it diverges. Right? It diverges. And then when this is divergence. And when it diverges, it sinks down again since it's now heavy, right? Subsides or sinks. So this diagram might look familiar from grade 11, of course. So what I'm basically trying to show you is that A in a high pressure is sinking or is descending, right? And then on a low pressure, it's ascending or increasing, right? And then let's talk about air circulation. So the air circulation inside a low pressure is always in the southern hemisphere, that is. I think this question should have been more specific, but in geography, you always assume southern hemisphere unless stated otherwise. So in the southern hemisphere, the air movement inside an anticyclone is anti-clockwise. And anticyclone is just a fancy name for saying high pressure, right? Anticyclone is anti-clockwise. And inside a cyclone, it will always be clockwise. Right? I hope that this is making sense to you. So with this having been said, A inside pressure C, which is a high pressure, is descending, that we can conclude, and it is diverging since you can see the upper A divergence towards a high pressure, right? So it's diverging and descending, which are options 1 and 4. 1 and 4, right? D. I hope this video has been helpful to you. I hope that you are able to grasp some of these concepts, and I do hope that you enjoyed this video. Do like and subscribe, and leave a comment for any other section you wish for me to do. Thank you.